Hello all. In this Biobits presentation, I will be going over CRISPR-Cas9. Basically, it is a gene editing tool, and I'm going to be going over a basic overview about what it is, how it works, and some applications you can expect to see in the near future. So before we can start talking about how we can expect to see CRISPR used in the future, first let's talk about exactly what CRISPR is. So founded in 2012 by scientists by the name of Jennifer Doudna and a group of her colleagues, they found CRISPR, which stands for Clustered Regularly Interspaced Short Palindromic Repeats. They found this occurring in bacteria, and basically all it is repetitive DNA sequences that can make identical copies with the help of a guide RNA. That's where the Cas9 comes in. Cas stands for CRISPR associated, and it's an enzyme, and it helps go directly into the inflicted area and just cut it out, and they go back together, and it is then transcribed through RNA and passed on. Now that we have an idea of what CRISPR is, I'm going to give a brief example about how it works. So if you look over here, pretend this long chain of paper clips is a DNA sequence. As you can see, there's one red paperclip, and pretend that is a monogenetic disease, which CRISPR wishes to fix. So with the help of the Cas9 guide enzyme, it will go in and delete it. If I can get it out. Connect the DNA back together, and then produce another one through transcription. Exactly identical. So at this point, you're probably wondering, what are the uses for CRISPR? Basically, its only use is for gene driving. And there's a lot of other things that come with gene driving and examples of how you can use it. But to explain gene driving, it's basically a way of pushing traits through a population much faster than normal inheritance would. CRISPR gives scientists the ability to introduce specific genes into a large population very quickly and broadly. One example of how gene drive can be so beneficial for humans is when we look at mosquitoes. So mosquitoes, believe it or not, are the most deadliest animal on this world, and that's because of the long list of diseases they carry. So a lot of scientists are using CRISPR to work with a small population of mosquitoes and take out their ability to pass on the diseases that they carry, such as malaria, dengue, triple E. And since mosquitoes reproduce so fastly, they will pass on those traits which are created by CRISPR, and now larger populations of those mosquitoes will no longer be able to carry those diseases. Back in 2018, a scientist in China was actually successful in using CRISPR on the first human trial, and it got a lot of backlash. It's kind of argued in the scientific community, but basically he went into an embryo of these two sets of twins that were bound to have AIDS because their father had them. And he used CRISPR to eliminate the CCR5 gene, which is responsible for AIDS. So if you look back on the example I showed with the paper clips, and remember that red paper clip, imagine that being the CCR5 gene and the doctor taking it out and producing the new DNA strand without it. So with any new technology, there's going to be a lot of fear behind it. And specifically with CRISPR, a lot of people have a lot of ethical and moral questions as to why it should be used and how it should be used. Specifically, a big concern for the people is the idea of designer babies. While this is a possibility of getting rid of a gene that makes you short or an undesirable hair color, I believe that it won't be taken that way. And the amount of good that CRISPR can give far trumps the bad. So in conclusion, you should definitely plan on seeing CRISPR more often in the future. Just look in the news. I know I've been seeing a lot in the news on my news feeds, and I truly believe this is a massive step for the scientific community, and it provides many benefits and solutions to problems that the human race has. And I think it's a very great technology, and you should too.